Video will discuss the definition of the three measures of central tendency for a data set, including the mean, median, and mode. The video will also show when to use these three measurements, how to make calculations for each, and summarize information for practical application. First, we'll start with the definition. The mean is simply the sum of the scores divided by the number of scores. This measure can only be used with interval or ratio level numerical data. The median is the middlemost score when the scores are ordered from smallest to largest. If there is an odd number of scores, then there will be one middlemost score. When there is an even number of scores, there will be two scores in the middle, and one would just simply take an average of these two scores to obtain the median. The median, as a measure of central tendency, can be used with either ordinal or interval ratio data. The mode is the score with the highest frequency of occurrence in a data set. A data set may contain a single mode, multiple modes, or no mode at all. The mode as a measure of central tendency can be used with either nominal, ordinal, or interval ratio data. Although the mean is perhaps the most common measure of central tendency for numerical data, the mean tends to be affected by extreme scores or outliers. On the other hand, the median is less affected by extreme scores and hence is often the favored measure of central tendency for distributions that are highly skewed, such as incomes. While the mode is a popular measure for central tendency for nominal data and sometimes ordinal data, it tends to be least used of the three for interval ratio data. Elena will now address when to use the mean, median, and mode.
How data is collected will influence when to use mean, median, and mode. Generally, scales are designed to utilize one of four levels of measurement discussed earlier in the video. These levels of measurements include nominal, ordinal, and ratio or interval data sets. Nominal scales or nominal surveys measure using categories. The responses from nominal scales do not have any numerical value. For instance, a true-false survey or a male-female question on a survey are examples of nominal scales. These responses are very limited and therefore can be assessed using mode function only. Frequency of a response may be used as a description of a particular demographic or environment. Ordinal scales measure variables in a particular order in relation to each other. Both median and mode functions may be used to determine patterns amongst these responses. Depending on the survey design, mean, median, or mode can be used when assessing interval and ratio scales.
I'm Matt Farber. I'm going to talk about mean, median, and mode and how they're calculated, kind of behind the curtain of SPSS and Excel. Mean is the most common type of descriptive statistical central tendency measurement. The average or arithmetic mean is calculated by adding up the numbers in a group, or sigma x, the sum of the numbers in the group, divided by the sample size, or lowercase n. There are three steps. First, list the data set values in columns, like in a table. The values represent x in sigma x in the equation. Second, add up the values, and finally, third, divide that by the number of reported values, or n. To calculate mean in Excel, select average from formulas, then highlight the column that you are calculating the mean in. Median is the midpoint of data set values. It is the middle of the scores. To get that, you would list the values in ascending or descending order. Once listed in an order, either up or down, review the data. The median is the middlemost point. If the median scores between two numbers in a data set, say 49 and 51, then take the mean of those two scores. In this case, that would be 50. Mode is the most frequent data in a list of data, or datum in a list of data, more precisely. If it is nominal and mutually exclusive, such as whether someone is Republican or Democrat, then mode would be the most appropriate central tendency measurement to use. You can't calculate the mean or median of someone's political affiliation, for instance, or the color of their hair, for that matter. You can't be, 40% Republican, technically, if it's mutually exclusive. Here, a table of values would also be useful. Simply list each value each time it occurs, then count how often a data point appears, and the most frequent item is the mode. So if there were 15 people who self-reported Republican and 10 who self-reported Democrat, then their mode would be Republican. The median and mode can be selected from the formula box in Excel. All three, mean, median, and mode, can be calculated using the Descriptive Statistics add-on tool, which results in a table that reports all the data. In SPSS, data can be identified as, quote, nominal, which would prevent the application from reporting the mode of something that is mutually exclusive. This is a very helpful fail-safe when describing sets of data.
So this is Johanna, and I am going to be explaining the mean, median, and mode using a practical example found in How to Lie with Statistics by Darrell Huff. In Chapter 2, it talks about an example that if a person wanted to move into a neighborhood based on the income reported from its residents, and the real estate person is telling you that the average income for the neighborhood is about $15,000, so you would want to maybe move into that neighborhood. But then afterwards, there's a survey a year later going on because they want to reduce the fare, because the bus fare, because a lot of its residents do not make a lot of money. We're like, wait a minute, what's going on here? Which one is true? Either the average income is $15,000 or the average income is going to be $2,000. So when we look at descriptive statistics, they're both correct. And looking at the picture, you see taking from everyone the mean or the average income from all its residents, it's going to be about $5,700. Why is that? When you see that at the bottom, $2,000 seems to be the mode. And then we have the median, which is $3,000. So what happens is you have an outliner, which is $45,000. You have a person that's making all this money, but then you have the mode, which is $2,000, which is the most frequent salary that the residents make. And the outlier, which is $45,000, is throwing off the average, which is $5,700. So you only have one person actually making, earning $5,700, and you have the median, which is the person in the middle, meaning 12 people make above $3,000 and 12 people make below $3,000. So in statistics, depending on what they're talking about, the mean, median, or mode can be used to describe the same different numbers and have different meanings.
Using The Biggest Loser as a data source, we were able to extract 15 seasons worth of winners and runner-ups. On the left-hand side, we have a listing of the weights of the winners at the end of the Biggest Loser competition and the weights of the runner-ups, or how much weight was lost. On the right-hand side, we used an SPSS program to determine the mean and the median of the runner-ups and the mean and the median of the winners. The group mean of the 15 data points for runner-ups was 135 pounds, whereas the average for the winners was 170 pounds. Of the 15 runner-ups, the median weight loss was 120 pounds, whereas the winners' median weight loss was 157 pounds. The data set did not have a frequently recurring weight loss poundage for the winners or for the runner-ups. Therefore, the mode was not there. On average, there was about a 30-pound or 25-30 pound discrepancy between the winners and the runner-ups in mean and median.
So that concludes our explanation of mean, median, and mode.